Thank you for watching this video demonstration of how to create a correlation matrix and a corresponding scatter plot using Jamovi. So when we're interested in relationships between two numerical or quantitative variables, correlation is our go-to. And through Jamovi, we can get a correlation matrix, which gives us the output that helps us understand the nature of the relationship between these two variables in terms of strength and direction. In this video, we're going to go step by step on how to create that correlation matrix and corresponding plot. But before we get to that, we need to prepare our data to be ready for this analysis. Jamovi requires that the measure type of the variables that we want to test are set to continuous or ordinal. In this class, we typically are really only interested in continuous variables, so we want to make sure that our data is set to continuous measure type. How do we do that? Let's go over that. So we can see that these are the variables in our data set. We're going to look at some of these, but let's change all of the measure types as if we were going to look at all of the relationships or all of these variables relationships. So we'll double click on the header. And this opens up the data variable field, and then we're going to select continuous from this drop-down menu. We see that now the icon here, instead of the three intersecting circles, has changed to this measure stick or ruler. So then when we close up that data variable field, we'll see that little ruler right next to age, which was the first column. We'll do that for our stress column. We can even arrow over if we had to do multiple columns, which we're doing in this case. So we want to make sure that they're all set to continuous, and then we'll close up our data variable field, and then we see the little ruler next to all of the names on the column header. Okay, so that means that all of our data is prepared for analysis. Now we are going to go up to our menu, select regression, and then correlation matrix from that drop-down menu. In this box here, this unlabeled box, you can see in the very right-hand side, this indicates that the only measure type that they will run, or Jamovi will run, a correlation matrix is continuous or ordinal. That's the ordinal icon, the little graph there or histogram. So if you're running into issues where it won't run a correlation matrix, go back and make sure you check the data variable measure type to make sure that it's set to continuous. Sometimes that's all it takes in order for us to troubleshoot if we're not able to run a matrix. Okay, so now let's look at our first relationship. We want to look at age and stress. So when we move those two variables into this box, we get some initial output. Here's our Pearson's R, which is 0.58. We get two pieces of information from this value. One is that it's a positive value, so the relationship between age and stress for this sample is positive. And then the value of 0.58 is above that threshold for a strong relationship. So 0.50 and above is considered strong. So the relationship between age and stress is a strong and positive relationship. We also get degrees of freedom, and then the p-value, and this p-value is 0.002, which indicates that it's statistically significant because any p-value less than 0.05 is considered statistically significant. If we were questioning our evaluation, we could select flag significant correlations. This will give you a little notation here of 2 asterisks. And if we look down here in the note, 2 asterisks is saying that the p-value is less than 0.01, which in this case it is, right? The other thing that we want to get from our correlation matrix is the confidence interval. This gives us our lower bound estimate of 0.24 and our upper bound estimate of 0.79. So those are the values that we want to get for our correlation matrix. Down here, we can select correlation matrix plot. This is our scatter plot. This could be helpful in sort of interpreting the relationship visually. When we're trying to put it into words, it can be helpful. So on the plot, we see here our X value. This is our predictor, which in this case is age. And on our Y-axis is our outcome, which is stress. What we can see here is that it's going up towards the right, which indicates that as our participants report being older, they also report higher stress. So as we increase on X, we also increase on Y. The other thing that we can see in terms of the graph here is this gray area. This is Jamovi's way of showing sort of the variability, how close they are. In a typical scatter plot, you would see all individual dots of each participant's value of X and Y. In this case, they give you sort of an idea of the variability around the line, how much scatter there is. 0.58 is a strong relationship, but it's not a perfect relationship. So if this, for example, was a positive one, which is a perfect relationship between age and stress, we wouldn't see any of this gray. It would just be one line. And I'll show you sort of an example in just one second that's pretty close to a perfect relationship and what that looks like. But just to conclude, this is our correlation matrix for age and stress, and its corresponding plot. So if I go back to, I just want to go back and do a new correlation matrix. And I'm going to do stress and sleep. I want to know what is the relationship here. And so we can see the initial output is giving us a Pearson's R of negative 0.99. This is almost a perfect relationship, right? 0.99 is almost 1. So this is a perfect negative relationship between stress and sleep, which makes sense, right? We can see the p-value is less than 0.001. But we could flag it just to be sure. Now we have 3 asterisks indicating that the p-value is less than 0.001, which we can actually see here. We can create our confidence interval, which is like a really large one. Is negative 0.99 and negative 0.97. That's our confidence interval around R. And then when we create our plot, now we can see a little hint of the gray beyond the line, but pretty much what this value of a negative 0.99 is indicating that the clustering is more closer to the line, where we're not seeing a lot of variability in scores. And how we interpret this is our X value, again, is stress, and our Y value is sleep. And what we're saying is that as stress increases, our hours of sleep decrease. So stress has a negative relationship with sleep, and that makes complete sense. I think we would all agree on that, right? So that's 2 examples of correlation matrix and scatter plots. Hopefully that was helpful. If you have questions, please let me know.